everyone! Good morning! This is your teacher Judy Ann and welcome to our video tutorial. For today's lesson, we are going to tackle about the power and roots of signed numbers. First, we will define what is power. The power of a number indicates that this number will multiply according to an exponent. This is the symbol of a root and its elements. As you can see here, the line above is the radical symbol, and the A here is the radical, and the X is the root. And as you can see, the below of the A or the radicand symbol is the radical. So the left side of the radicand is the N, which is the index. So that is the symbol of a root. Now that you have learned to multiply signed numbers, it is possible to consider products in which the same number is repeated as a factor. For example, 3 times 3 times 3 times 3 is equal to 3 raised to the power of 4. So the answer of the 3 raised to the power of 4 is 81. Why? Because 3 times 3 is equal to 9. 9 times 3 is equal to 27. And 27 times 3 is equal to 81. So that is why 81 is the answer of 3 raised to the power of 4. In the symbol 3 raised to the power of 4, the number 3 is called the base. The number 4 is called the exponent and is written slightly raised and to the right of the base 3. The entire symbol is called the fourth power of 3 and is commonly read as 3 to the fourth power. If a base has an exponent is exactly divisible by 2, we say that it is an even power of the base. For example, 3 raised to the power of 2 and 5 raised to the power of 4. And negative 2 is raised to the power of 6. So as you can see that 2, 4, 6 are even numbers. So we can say that those are the even power of the base. If a base has an exponent is not exactly divisible by 2, we say that it is an odd powers of the base. Is for example, 10 raised to the power of 3 and negative 4 is raised to the power of 5 and 3 raised to the power of 7. As you can see that the exponent is 3, 5, and 7 are odd numbers. So we can say that these are the odd power of the base. Example of powers of signed numbers. So 2 raised to the power of 3 is equal to 2 times 2 times 2 is equal to 8. And the second example is negative 1 raised to the power of 5. So equals negative 1 times negative 1 times negative 1 times negative 1 times negative 1. So the answer is negative 1. Why negative 1? Because you can see the exponent here is an odd power. That is why the answer is negative. Note that an even power of a negative number is positive. An odd power of a negative number is negative. A word of caution. Students often think that expressions such as negative 6 squared and negative 6 squared are the same. They are not always the same. The exponent applies only is the same symbol immediately preceding it. So as you can see, negative 6 squared, there is a parenthesis. So it is equals negative 6 times negative 6 is equal to positive 36. So negative 6 squared, there is no parenthesis. So as you can see, negative 6 times 6 is negative 36. So the exponent applies to negative 6 and the exponent applies only to 6. Therefore, negative 6 squared is not equal to negative 6 squared. Positive of 0. If A is any positive real number, then 0 is equal to 0. Square roots. A square root of a number n is a number whose second power or square is n. Finding square roots by inspection. Example: 3 squared is equal to 3 times 3 is equal to 9. 9 is called the square of 3 second power of 3, written as 3 squared is equal to 9. So as you can see here, 3, it's called the square root of 9, written as the square root of 9 is equal to 3. Examples of square roots by inspection. So the first example is the square root of 4 is equal to 2. Why? Because 2 squared is equal to 4. We multiply it by 2 times 2. So the answer is 4. So the second example is the square root of 36. So is equal to 6 because 6 squared is equal to 36. So the third example is the square root of 0 is equal to 0 because 0 squared is equal to 0. We multiply 0 by 0. So the answer is 0. So the fourth example is the square root of 1. We already know that we multiply by 1 by itself is always 1. So the square root of 1 is 1. All the square roots discussed so far are called principal square roots. Every positive number n has both a positive and a negative square root. The positive square root is called the principal square root. The symbol, the square root of n, is used to denote the principal root of n. On the other hand, the negative square root of n corresponds to the negative square root of n. Finding square root by trial and error. Suppose you're asked to find the square root of 196. You know that the square root of 100 is equal to 10 because 10 squared is equal to 100. Therefore, the square root of 196 is greater than 10. Try 12. 12 squared is equal to 144. Therefore, 12 is too small. Try 13. So 13 squared is equal to 169. Therefore, 13 is too small. So we have to try 14. So 14 squared is equal to 196. Therefore, the square root of 196 is equal to 14. So, this is what we mean by finding the square root by trial and error. Finding square root by using calculator. There are methods for calculating square roots. However, calculating square roots manually or by using tables is rarely necessary today because of the availability of calculators and computers. For example, a calculator with a square root key gives the square root of 94 as approximately equal to 9.6953599114. So that is the value of the square root of 94. Roots other than square roots is called higher roots. Example. In the expression 2 cubed, as you can see here, 2 cubed is equal to 2 times 2 times 2 is equal to 8. So 2 is called the cube root of 8, written as the cube root of 8 is equal to 2. So the 8 here is called the cube root of 2, the third power of 2, written as 2 cubed is equal to 8. So now, that is the power and the roots of signed numbers. And now, please answer the following question.